Today I'm going to talk about the problem statement 18, which is DNN Inference Optimization Challenge. And you can also find the problem statement on our AdLeak wiki, which I have posted the link here. You can click it and find the problem statement and get all the details. And first I want to briefly introduce the background of the DNN Inference Optimization Challenge. You can see that since the development of DNN models, the models have been increasingly accurate since compared to the models before. But with the high accuracy that have been introduced, the high complexity is also introduced in the deep learning models. So you can see that all the models now, they have more and more layers and have millions of thousands of parameters, which all makes the DNN models more computationally expensive and memory intensive. And since before they are deployed on the cloud, so this problem is not that extreme. But now you can see the energy consumption of the data center is rising rapidly, and now more and more people are demanding for reduced latency, and sometimes they require for privacy. So many applications need to be moved to the edge. So this marks the development of edge computing. Since the edge computing is developing, we need to consider the deployment of machine learning models, including the DNN models to the edge devices. But there is a problem about the edge devices, which is the resource constraint. Actually, most of the edge devices have limited resource. For example, the CPU and memory, and they have limited energy. And to deploy the models on that resource constrained edge devices, we need to get the following problems solved. For example, the computation cost, memory footprint, and latency and power consumption, so that we can get efficient inference on the edge devices. That is our goal for the DNN inference optimization. Actually, there are several approaches for the DNN inference optimizations, which can be grouped into three types. First is the model optimization, which is which use some optimization techniques on the models, so that the model will get better structures and get optimized performance. And the next one is the kernel optimization. Examples are Intel MKL DNN and NVIDIA TensorRT. You get this accelerated computing libraries, and then you can boost your DNN network efficiency. And then the next part is about the hardware optimization, which is this part is about designing some hardware so that they can better adjust to the requirements of DNN networks. For example, the Intel Nice Landing CPU, which accelerates the computation of vectors, and then the NVIDIA Pascal GP100 GPU, and then the Google TPU, which are all designed for DNN networks. And also there are some embedded SoC chips, such as NVIDIA Tegra, which can be used as an edge device. And among these three types, this DNN inference optimization challenge will focus on the first type of optimization, which includes the model pruning, model quantization, and knowledge distillation, which are all approaches that applied to the models after a model is designed. So we don't take consideration of the first type, which is the efficient model design, although it's also very effective, but we consider only the optimization after the model design. So next, I will introduce some model art technologies that have been introduced in the model optimization technologies. First is the model pruning. Model pruning refers to the model compression technology of removing redundant connections. You can see from the picture below. Before pruning, which is a model just have been trained, you can see that all the neurons, all the connections, it is an over parameterized network, which is very essential for model before deployment and during training, because the over parameterization enables a neural network to learn the trivial information of all the training data. But after the training, these neurons and connections may not be that important as they are during training. So if you prune some connections, such as the weights or the neurons, the performance will not be reduced very much. So here is a traditional process of processing the pruning. So first you get a network, and then by some way you evaluate the importance of the neurons, and based on the evaluation results, you remove the least important neurons. And after that, you may find that your model is suffering from some loss of accuracy. So if you do some fine tuning, which is referring to some further training after the pruning, you will find that you can get the model accuracy a little bit improved. And after that, you can decide whether or not you should continue with the pruning, because if you prune a network too much at once, the model will suffer a big loss of accuracy. So most of the time you should try on the iterative pruning. And about the pruning, there are several challenges that remains to be solved. First of all, is how to evaluate the importance of parameters. So now there are many technologies about this part. You can determine by the L1, L2 means of the weights, or the activation weight. Activation means to get the importance of parameters, and then do the pruning. And you can design some of your own ways to do the evaluation. And if you have a good solution of this, we may think you have a very innovative approach. And the next part is about how to effectively reduce computation and latency. We put this because sometimes pruning may make the network more sparse, but it will not reduce the computation, because the pruning is irregular, which means that the hardware can hardly accelerate the operations of the network. And the next challenge is about how to recover accuracy. So here in the example, we listed the traditional way of fine-tuning. And in some papers, you can see that people may think training from scratch is also feasible. And you can design your own way to recover accuracy. Here is another way of model compression, which is model quantization. We can see from this this figure before. You can see that the weight before has many parameters, and if we use the k-means clustering method, you can cluster the whole values into 4 groups, which is 2.00 and 1.5, 0 and -1. And then the whole matrix can be reduced to a centroid cluster and a cluster index. And here are some challenges here. One is what to quantize. You can quantize activation, gradient, and you need to determine to what degree you want to quantize. Do you want to quantize it to 8-bit, 4-bit, 2-bit, or 1-bit? And then you need to choose parameters such as the step size, clipping value. And in the end, we hope that you can get a balance between the compression and accuracy. Actually, model quantization has many advantages for the model optimization. First of all, the memory size will be greatly reduced. If it's reduced from 32-bit float to 8-bit, it will reduce 4 times memory size. And then if most of the processors have better support for the 8-bit data to be processed. It will process much faster than the 32-bit float. And actually, moving the 32-bit float is much slower than the 8-bit. So the energy will be much reduced if you use the quantization. Here is an example of ADLIC pruning and quantization. As Thomas has introduced, ADLIC is an open source project in Linux Foundation, AI Foundation. It is proposed to accelerate the deep learning inference. It is a toolset to accelerate deep learning inference. And here we want to introduce 2 parts of the ADLIC, which are pruner and quantizer. And here the pruner supports channel pruning and filter pruning, which is used to reduce the number of parameters and flops. And the quantizer supports 8-bit calibration quantization. And after the pruner and quantizer, and then you can use the 8-bit inference. So take the ResNet 50 as an example. You can see that the baseline has the top 1 accuracy of 76.19%, and the pruned network just has a little bit loss of the accuracy. But the parameters and multiply and calculator operations and the size of the model is greatly reduced, about 1/3. And after quantization, the size of the model is further reduced to 1/4 of the pruned model. If you want to take pruning and quantization as a model optimization technology used in your solution, you may take this as a baseline. And here is the introduction of the knowledge distillation. Knowledge distillation refers to the model compression technology that teaching a smaller network step by step exactly what to do using a bigger already trained network. And you can see the picture you can see the picture that for the pre-trained teacher model, it can generate some predictions from the training data, and all the predictions are can be seen as soft labels, and they can be fed into the student network, and so that student can learn from the soft labels and all the true labels, and so that they can it can get the distilled knowledge from the teacher. So this technology exists because the student network is often very small compared to the teacher network. So if you don't have the teacher network, it may be very hard for you to train a model with the training data that you have. And for knowledge distillation, there are also some challenges you can deal with. First is introduce multiple teachers, which can be used as on sample models. And then you can also introduce a teacher assistant, which means that you can teach the teaching assistant with the teacher network, and then you teach the students afterwards. And here is another model optimization technology called model partition. And so here you can see that for now, most of the models are deployed on the cloud. And for the approaches before, we think that we can compress the model so that they can be deployed on the mobile devices. And this paper proposes that the models can be divided into two parts. One part can be deployed on the cloud, and one part can be deployed on the mobile phone, so that it will greatly reduce the end-to-end latency of the inference, and then also improve the throughput of the data center. Also, since the model is not all deployed on the mobile phone, so the mobile can have a greatly improved power consumption. So all the approaches before, I want to show you that all the approaches to the models can be applied by you to solve the tasks of our DNN inference optimization. And in detail, we can see that our task can be concluded as the picture here. So we provide three base models, which are NLP model, BERT, and image classification models, which are MobileNet v3 and ResNet 50. So all you have to do is to select a model from the target models, and then design and implement your own optimization solution. And finally, you should achieve the goal that of boosted compute computing efficiency, reduce the memory footprint, and improve the latency, so that you can get an efficient inference. And these models are some examples. If you have more models to be used by your optimization solution, we think that's better. And for the submitting, you need to do 2 steps. First, you need to create a private GitHub repository to contain your work, and then you should add AdLeak challenge as a collaborator. This GitHub account is created to get all the submissions from you, and your repository must be made public before submission deadline and should be accessible till the end of the final event of the ITU challenge. And after you add the AdLeak challenge as a collaborator, and then we will get a notification, and then we will start your repository. Then you can work on work on your solution, but don't forget to make the repository public before submission deadline. And you need to submit 2 kinds of things. One is the source code, which will contain all the whole optimization solution, and you should contain a performance test demo to show that your optimization is good enough. And also the description document should contain 2 parts of things. The first is instruction on how to verify the optimization performance with the source code, and other constraints of the document should include, but are not limited to, insight, opinions, and analysis of model optimization, selected target model, and reason, base model, solution, algorithm used, description, and comparison of model optimization results. And for your solution, we don't have a very registic formula to calculate your solution. So we have 4 criteria for your solution. First is effect of your model optimization. We hope that you can get a reasonable trade-off between accuracy and efficiency. And the selected model type, loss of accuracy, compression rate of model parameters, and the computation will be taken into account. And then we need you to show the solution advantages. We need to see whether the solution is reasonable and whether the solution has enough practicability, innovation, and university. We hope that your solution can be generalized to more models and easy to implement. And the next criteria is about the problem analysis, whether this is a deep original insight into the problem, and whether the analysis of the key elements of the problem is accurate and reasonable. And finally, the last criteria is about the completeness. We hope that you complete your solution and you complete all your solution and get all the source code on GitHub. Whether the requirements of the computation are fulfilled according to the proposed scheme and design. This is what we want from you. And in the end, I want to give you a few tips about how to participate in the challenge. First, you can see the problem statement on AdLeak Wiki, but I think that all the details I have put on Wiki has been introduced by me just now. So you can just directly sign. You can directly register for the challenge. First, you need to have an ITU account. and you can follow the guidance from the ITU, and then you should register on ITU AI ML in 5G challenge website with your ITU account. And then you should fill out the survey to select problem statement, which is problem statement 18. You can enroll as a team with 1 to 4 members. And next, you can start to work on this problem and submit your results. And we will begin to accept submissions from July 1st to 2020. And the submission deadline is October 10th, 2020. And every other things, you can see the ITU notifications. Thank you, that's all. Any questions?
Thank you so much, Leah, for this wonderful presentation. Now it's time to invite my colleague Vishnu for the Q&A session. So I will leave it into your able hands, my colleague Vishnu. You can take over now for the Q&A session.
Yeah, thanks, Thomas, and thank you, Leah. Excellent presentation as usual. It is always a pleasure to talk to Leah. She's my great collaborator for a long while. I just had some questions of my own. What kind of file formats are we looking at? So do you accept? Do you look for any particular type of file formats? So the models, if I'm a participant, I create a model and I train it, and do I need to export it to a particular format, or what is your expectation, please?
No, you can have any format as you like. You can choose TensorFlow or Caffe as you like.
Okay, very good. And could you go back to your output that you were explaining? Okay. I think one of the last slides you were explaining what you are expecting, and there the output which is expected. Yeah.
This one.
No, the one before, right? Yes. So here, do I need to submit the model, the produced model, or what do you expect here?
Yes.
Okay, and yes, I see base model and algorithms used. Okay.
Yeah, do I need to add that in as a complementary description of the source code?
Oh, sure. I think that will be good. Yeah, but yeah, sure. Yeah, that will be useful. Yes. Another thing, one of the questions which is being asked is where do you apply these models? I mean, I think it is a generic question. So, for example, you remember the use cases that we discussed, right? So, we talked about in the context of focus group that these AI models, ML models can be applied in the RAN or core for different use cases. Could you, I think, explain the relationship? For example, if you use Idyllic or one of these frameworks for model optimization, finally, how do I deploy in the network, in the RAN or core, and what do I do with it? Could you give us a little bit of description as to why do we do all this? I mean, yes, Idyllic, yes, I compress. Now, what do I do in the 5G network, RAN or core, or what do I do with it, please?
Yeah, first of all, in RAN or core, there are some devices with limited resources. So first we compress them or do other optimization, and then you can get a smaller model, and you can run it on RAN or other devices with improve the latency. So this is very important, especially in 5G network, because there are many edge computing scenarios here. For example, you may want to deploy the models on the scenarios such as autonomous vehicle, right? Here you need the latency is very important. And about the deployment ways you just mentioned, I think that you can use about you can use two ways. First is you can integrate the ML model in your AI application, so you can invoke the model inference from the process, or you can host the whole model inference as a service in a Dockerized solution, and then you can get the inference from the web service. Did I answer your question?
Sure, sure. Yes, yes. I think that's a great answer. I think it corresponds to what work which we did last year as well. I just want to go back to your one of the first slides. I think second slide or so. Could you go back? You had this iterative one more down. Yes, the iterative model of optimization. You had a pipeline in the fourth slide.
Fourth slide.
Yeah,
this one?
Yeah. So how do I know when to stop? So you have this nice pipeline over here, and it is going back again and again. So how do I know when to stop? So I might have a as I am thinking that as a participant, I can go on and on with this, optimize how much ever I want, prune a lot of things, lot of neurons, but how do I know when to stop and when when is it being counterproductive to do this pruning, and how do I benchmark things, please?
Actually, about the benchmark, I just put a benchmark which you can use about the analytic pruning and quantization. Here you can see some parameters of the performance. You can use this as baselines to do some benchmark test. That's the first point. And then about the continual pruning thing, you mean you don't know when to stop, right? Yeah, I think that's part of your algorithm. You can determine when to stop based on the accuracy and the compression rate of your parameters. And actually, you can choose a lot of ways to do such things. And almost you can use AutoML technology to automate all the process of the pruning thing.
So do I as a participant, do I get points for using AutoML, or is it better to do my own techniques, or what are you looking for here?
Actually, our principle is very simple. You can choose your. It's very simple and flexible. You can choose your own methods. We advocate AutoML technologies as long as it shows great efficiencies on the model that we proposed about the BERT or ResNet or MobileNet. If it shows great advantage, and we will think that's a good solution.
Interesting. And one more question is about how much I should know about the problem and the data, right? I mean, we discussed this before about domain knowledge and the importance of domain knowledge, and what suppose it is e-health data. Okay, I don't know anything about ultrasound or anything like that. So you have data from these domains which I don't know anything about as a participant. So does it matter that I train my data and optimize without knowing anything about the data, or does it help if I am the domain expert? If I'm a medical professional, I would know anything about ultrasound, I would say. So does it help to have a domain expert here or not to do the pruning or any of these techniques that you're explaining, please?
Sir, sorry, you speak too fast and I can't understand or. So what do you mean by saying domain knowledge?
The knowledge about the type of data that we are using. So I could have images from X-ray or medical data, right? I could have such data which I don't know anything about. I'm not the domain expert. I'm not a doctor. I don't know anything about it. But if, let us say, if a doctor looks at it, or a medical professional looks at the X-ray, she may know something about it. So she may know that if the network is performing well or not performing well based on the pruning techniques that you're using. And I am not a doctor, and I am at a disadvantage because I don't know anything about it. I don't know how the network is performing. How do I, is it important, the type of data that I know something about the type of the data to do, choose the pruning techniques and quantization techniques or any other techniques that you are explaining?
Actually, I'm not sure I understand all the questions you have asked, and I'll try to answer some. And if you think there's a problem, you can point out. Okay, I think that the domain knowledges are not quite important here. I think the domain knowledges are like the knowledge that introduced by, for example, Francisco or the professor before. They have gave a presentation before and show their own challenge problem statement, and all of this involves some 5G network technology background knowledges. But for this problem statement, I think there is not many domain knowledges involved here. We proposed the problem statement as the I don't know, enabler track, right? So it's kind of not quite related to, it's not very specific to the 5G network. So for the network, you first of all, the models that we selected are very general and famous networks that you can see here. And you can do all the work if you get to know the structure of the network, about the for connected layer and the convolutional layer. You know all this, and you can do the work.
Interesting, very interesting. Yeah, thank you. So there is a question which is asking about the language which has to be used to do this source code, I guess. So I guess in one of the slides, I think in your expectations, you have told about source code. So I guess that's where the question is coming from. Which language has to be used, please?
Yes, you can use any languages. Python or Julia, yes, okay.
Very good. I think benchmarks. So yes, I had this question for a long while. So you did talk about benchmarking, right? How
Yes.
do I benchmark? Are there tools available? How do I check the parameters of my model as a participant? What should I do to benchmark these models?
You can choose your own methods, and the parameters you can choose for the benchmark are like parameter numbers and flops or multiply and calculator operations, and the final size of the model. And you can choose any tools you can use to get metrics like this. And also, if you like, you can have your own metrics, and but you need to make sure that you have better performance with your metrics. and I need that all the metrics you choose is about the computation cost and the memory footprints and about this. Yeah.
Could you go to your tips? There was a slide which talked about tips.
And talk about what?
The tips to.
Oh yeah. Okay.
Yeah.
Okay.
Yeah. So so I want to also ask about you know what how do I win this, right? So as a participant, I want to maximize my chances of winning. So could you give some tips on what makes you differentiate between a top entry and maybe not so good one, please?
So I think that's based on the evaluation criteria.
Okay.
And we will select the top 3 or top 5 members of the participants and with this evaluation criteria.
Mm-hmm. Okay. So let us say you know, it is I'm sure previous studies would have been done on this topic, and optimizations would have been tried out by many researchers in this topic. What are your could you tell the participants what are your current feeling, current numbers, current benchmarks that which current research shows as a benchmark?
You mean what do most of the researchers do when they pick their?
Yeah.
I think it's about this. You can choose your own metrics about all of these things. You can say you have saved how much computation cost, and you can use metrics, and you can measure the latency with the tool you can use. That's not a very static standard, I think.
That is interesting. Okay, that sounds good actually. Yeah, I did not think about it. Okay, I want to also ask you about Adelic, and in general, what are the next steps? I know you are the best. I know you are the best person. So what is going to happen after the challenge? So you get let us say you get a very good participation. You have these techniques which are being studied by these participants. Could you tell us a little bit about where Adelic is going and how this is useful? Maybe as a participant, would I get a chance to contribute or merge my code? Let us say, you know, I become a contributor. Let us say, or could you tell us a little bit about Adelic and its future and how it is related here? Thank you.
Thank you for reminding. I wanted to mention that, but I forgot. And now I thank you for for these tips. Actually, we hope that after this competition, we have more insights about the model optimization technologies, and hopefully. We wish that the participants with good solutions can get into Adelic community and contribute to their code to Adelic as a contributor, if you like.